elementary operations. Operations or transformations of matrix. There are some operations which we will perform on a matrices. See, first operation is, suppose we have a matrix A. Matrix A is 2, 3, minus 1, 6, 0, 2, 1, 5, minus 2. This is a matrix A. Now, first operation is, suppose I want to interchange first and third row among themselves. So what we do, first row and third row, I am interchanging. So third row it will be in first place and first row will be now third row, second row as it is. So this operation is denoted by this symbol. First row and third row are interchanged. First and third row are interchanged. So we have applied this operation. Suppose we have a matrix 2, 1, 6, 9. This is a matrix. It can be done over columns also. Suppose we want to interchange these columns among themselves. So first column and second column, interchanging among themselves, applying this, we get a new matrix. First column is now second column is now first column is now second column. So here interchanging any two rows or ith row or column, interchanging ith row or column with jth row or column. This is denoted as interchanging ith row with jth row or ith column with jth column. So this is first basic operation. Now second operation. Suppose matrix A is 2, 1. Suppose I am taking same matrix 2, 3, minus 1, 6, 0, 2, 1, 5, minus 2. Now what we do? We want a new matrix such that I want to multiply any one row by a non-zero constant. Suppose third row I want to multiply by 4. Third row I am multiplying by 4. So multiply this by 4. So 1 into 4 is 4. 5 into 4 is 20. Minus 2 into 4 is minus 8. Third row is multiplied by 4. So this is denoted as third row is multiplied by 4. Third row, doing changing third row. What we are doing in third row? Third row is multiplied by 4. So we have applied this operation. First and second row will keep as it is. Similar operation can be performed over columns also. Suppose E is equal to 2 minus 1, 3, 0, 0, 4, 1, 6, 9. Now here, first column I want to multiply by 3. First column multiplied by 3, so 6, 0, 3. So first column, we are doing changing first column. First column, it is multiplied by 3. If you multiply by minus 3, okay, here minus 3. Suppose if I multiply this by minus 3, so this will be minus 6, minus 3. So I will take the minus. Second and third column as it is. So we have applied this operation. So second operation is multiply elements of ith row or ith column by a non-zero constant k. So notation is multiplying ith row by k or multiplying ith column by k. So this is the symbol which we are using. Third operation. Suppose matrix A is 2 minus 1 minus 1 0 1 5 1 3 4. Now here what we want to do, elements of first row I will multiply by this number 5. Elements of first row I will multiply by 5, and whatever will be products I am adding in second row. So I will do change in second row. Multiply elements of first row by 5. Keep products in your mind. Don't change elements of first row. Multiplication orally. Then whatever are products, add in second row. Second row will be changed. So say it like this. First row keep as it is. Now I am doing change in second row. Multiplying this by 5. This will be 2 into 5, 10. Add here 10. 0 plus 10 is 10. Then minus 1 into 5 is minus 5. Add here minus 5. So minus 4. First row is multiplied by 5. Minus 5. Add here minus 5. So it will be 0. So change will be in second line. Second line will be changed. No change in first line. Third row as it is. So say second row is changed. So second row is changed. What is done in second row? In second row, we have multiplied first row by 5 and products are added in second row. Second row is changed. So what is changed in second row? Second row will be converted into this procedure. Multiply elements of first row by 5 and products in second row. So applying this procedure, we get this matrix. Suppose matrix B is 169 minus 241 10 2 3. Now second column I want to subtract in third column. So this column I want to subtract in third column. That means this column I am multiplying by -1 and adding in third column. So here first column as it is, no change in second column. Multiply is only. Whatever is product, add in third column. So this will be changed. Now look, 6 into -1 is -6. Add -6, so this will be 3. 4 into -1, add -4, so -3. 2 into -1, -2, so 1. That means 6 is subtracted, 4 is subtracted, 2 is subtracted. So here from third column, second column is subtracted. So third column, change is in third column. What is done in third column? Second column multiplied by -1 and it is added in third column. So multiplying -1 and adding product, that means it is nothing but simple subtraction. C3 minus C2. So similarly, you can add also. Addition, direct addition, that means keep plus. Subtraction, so keep minus. So applying this procedure or operation, we get a new matrix. So this can be written in words like this: multiply elements of ith row or jth row, multiply elements of jth row, multiply elements of jth row or column by non-zero constant k and adding products into corresponding elements of ith row or column, multiplying elements of jth row or column by non-zero constant k and adding products into corresponding elements of some other row. Notation is, see, adding products in ith row. So ith row will be changed. What is done in ith row? In ith row, elements of jth row multiplied by k and values are added. Or ith column, change in ith column. In ith column, after multiplying elements of jth column by k, values are added. So these are the notations, and this is the way of performing this elementary operations. Inverse of matrix. Let E be a square matrix of order n. if there exists another square matrix of same order M, another square matrix B of same order M, such that product A into B, multiplying B from right side, this is identity matrix. Or if you multiply B from left to A, then also we get identity matrix. This is identity matrix of order M. Then B is said to be the inverse matrix of matrix A. It is denoted as A inverse. So here B is A inverse. If we can find matrix B such that A into B equal to B into A equal to I, then B is said to be the inverse matrix of A. So that is B is A inverse. And matrix A is said to be invertible matrix. It is said to be invertible matrix. Now see, replacing B by A inverse, we get A into A inverse equal to I equal to A inverse into A. Taking product of any matrix with its inverse from either sides, result is identity matrix. And one more result for matrices A and B of suitable order, these are square matrices. For square matrices A and B of suitable order, A into B inverse, it is equal to not A inverse into B inverse, this is equal to B inverse into A inverse. Inverse of AB is equal to B inverse into A inverse. So remember this result. Now method to find inverse of matrix. Method to find finding inverse of given matrix B. And this method is method of finding inverse of given matrix A using operations or transformations. Using operations or transformations. There is a method how to find inverse of any matrix. So in this method we shall use operations or transformations. Just I explained. There are 3 operations on rows and 3 similar operations on columns. If we find inverse of matrix using row operations, if we find inverse of given matrix A, then in this method starting is start by we will start by this step. E is equal to I into A. A equal to I into A. This will be starting, and its end will be at end. Last step will be on the left side. Here we will convert I, and here something will be derived. I will be replaced by B into A. So this will be A inverse. See, you will not able to understand whatever I am speaking here. This can be understood in example. So when I explain example, you will able to understand this procedure. Second, using column operations. Using column operations to find inverse of matrix. In this procedure, starting will be from E is equal to E into I. This will be the starting of the procedure, and end will be last step will be here E will be converted into identity matrix, and here E into B. I will be converted into B. So this will be required A inverse. And in this procedure, at any step, if we get all entries 0 in any one or more rows, then inverse does not exist. In any step on the left hand side, if we get all entries in any row zeros, then A inverse does not exist. And when performing this procedure, if in any step in left hand side, if we get all entries in any column zeros, then A inverse does not exist. See, whatever written these two statements at present, you will not able to understand. This will be understood in procedure. I will explain this procedure in example. Using elementary transformations, find the inverse of each of the matrices in exist. Here, first matrix is E is equal to, this is the matrix. Now, just I explain. Using row operations or using column operations, we can obtain inverse of matrix. So first I explain using the row operations. So method 1, here explaining using row operations. Using the row operations, we start by this step. Here I explained starting. Using row operations, starting step is, we know that A is equal to I into A. This was starting. A is equal to I into A. Implies, now we keep value of A. A is 2, 0, minus 1, 5, 1, 0, 0, 1, 3 equal to identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1 into A. A keep as it is. This A we forward as it is in every step. Only changes will be in A and I. We will do parallel changes using the row operations. So this will be the starting. A is equal to I into A. Keep value of A on left side, don't keep on the right side. Now, as I explained in procedure, last step will be, here left hand side is A. In the last step, left hand side will be I. And here on the right hand side, wherever I is written, I will be replaced by some new matrix B. And this A will be forwarded as it is till last step. So this will be changed. New left hand side, this will be matrix on the right hand side. So this A we are going to convert in I, and to convert A into I, whatever we do in this matrix, same procedure we will perform in this matrix. So this will be also changed into a new matrix, and this will be our A inverse. This matrix will be inverse of matrix. Now, so that means last step will be here 1, 0, 0, 0, 1, 0, 0, 0, 1. At last, there should be last step. I equal to something into A. So you can see that this is first step. This will be last step. In last step, left hand side will be I. So here LHS we are going to convert into I using row transformations. Now see, steps one by one. In this procedure, first step is set 1. Set 1 here. We want 1. Here 1 is not given, 2 is given. Here we want 1. So what do we do? We divide this row by 2. Dividing first row by 2. So first row I am dividing by 2. So dividing by 2, this will be 1. 0 divided by 2 is 0. Minus 1 by 2. So first row dividing by 2, we are getting 1. Now whatever you do in left hand side, same procedure do in right hand side. So because here this is divided by 2, same operation on first row on the right hand side. So dividing by 2, 1 by 2, 0, 0, 0, 1, 0, 0, 0, 1 into A. Whatever procedure you perform in the left hand side, same procedure perform on right hand side. Left hand side steps will be created by observing last requirement, and here there will be parallel creation on the right hand side. So what is done here? So whatever done here, showing the reason here, first row is multiplied by 1 by 2. This is done. Second and third row as they are. Second and third row as they are. So one is created. Next step, concentrate here. Then next step, create 0. After 1, get 0. Go through column. Now here we are going to create 0. Here I want 0. So what we do? To get here 0, first row multiply by 5 and subtract in second row. So this will be then 0. First row multiply by 5, subtract in second row. 1, 0, minus 1 by 2. Now this I am multiplying by 5 and subtracting here. So this will be 0. Multiply by 5, product is 0. Here no change. Multiply by 5. So product is minus 5 and subtract here. So 0 minus 5 by 2, that is plus 5 by 2. And whatever is done here, same procedure here. What is done? First row multiplied by 5, subtracted in second line. So here first row multiplied by 5, subtract in second line. So here multiplying this by 5, it will be 5 by 2, subtract here, so minus 5 by 2. Multiplying 0 by 5, no change, subtract 0. 0, 0, 1, 8 forward as it is. So what is done here? We have changed the second line. Second line is changed, second row is changed. What is done? In second row, first row after multiplying by 5, subtracted in second row. So this is elementary operation perform over row. Whatever you do here, same thing you will do here. So this was done to set here 0. So the 0 is obtained. Look on left hand side. On left hand side we are getting in this sequence. First of all, get 1. After getting 1, get 0. So that is done. Now third step. This was first step, this was second step. Now third step, get 0. So third step, focus here. In third step, set here 0. Now look here. Already here 0. Already it is settled. So third step is done. No need to set here 0 because already 0 is there. Otherwise, you have to change here if number is non-zero. So third step is done. Now fourth step. Fourth step, set 1. Fourth step, set 1. This will be fourth step. Then this will be fifth step. Then sixth step, 1. It's a sequence. First step, second step, third step. Now fourth step. We are going to create here 1 on the left hand side. Look here. Here we want 1. It is already there. So fourth step is also set. So this is done. 1, 2, 3, 4 done. Now look here, fifth step. We need here 0. we need here 0. Fifth step. Now see here, there is no 0. So to set here 0, what we do? Observe element exactly above it. This is 1. So second row, if we subtract in third row, then this entry will be 0. Second row, we are subtracting in third row. So doing this in the next step, 1, 0, minus half, 0, 1, 5 by 2. See now second row I am subtracting here. So 0 minus 0 is 0. 1 minus 1 is 0. This will be subtracted. 3 minus 5 by 2. So 3 into 6 minus 5, 1 by 2. Second row is subtracted here. Same operation we perform here on the right hand side. It is equal to 1 by 2, 0, 0, minus 5 by 2, 1, 0, and now second row I am subtracting in third row because this was done here. So subtracting this here, this will be 5 by 2. Subtracting 1 in 0, it will be minus 1. Subtracting this into 1, 1 remains unchanged. Into 8, into 8. So what is done here? We have done change in third row. What is done in change? What is done in third row? In third row, second row is subtracted. So this 0 is okay. So remember, whenever to get this 0, always take help of this line. To get these two zeros, take help of first row. So fifth step is done. Here 0 is okay. Now sixth step, get this one. Sixth step, get this one. So look here, we want here 1. So to get here 1, because these are zeros, we multiply this by 2. Multiplying third row by 2. So multiplying third row by 2, here we will have 1. This is multiplied by 2, hence this side also, this line I multiply by 2. It is equal to 1 by 2, 0, 0, minus 5 by 2, 1, 0, multiplying by 2, 5, minus 2, 2, into 8. So what is done here? Third row is multiplied by 5. Sorry, it is multiplied by 2. So say 1 is okay. So look, first of all, we set here 1, then second step, then third step, fourth step, fifth step, sixth step. Always get digits 1 and 0 in this sequence on the left hand side. First step, second step, third step, fourth step, fifth step, sixth step. After getting sixth step, using this line, get here 2 zeros. Using this line, we can set here 2 zeros. So, using this line, now we can set here 0, 0. So what we do? To get here 0, this will multiply by 5 by 2 and subtract in second line. As well as third row, we multiply by 1 by 2 and in first row. Two operations at a time. Say here 0, 0, 1. Using this line, we are going to send here 0, 0. So see, first of all, I send here 0. So this is 0, 0, 1. This is minus half. So I should multiply this line by 1 by 2 and I have to add in first line. So multiplying this by 1 by 2, because these are 0, 0, no change in product. So 0 into 1 by 2 is 0. So add here 0. So 1 remains unchanged, 0 remains unchanged. Now 1 into 1 by 2 is 1 by 2. Add here 1 by 2, so this will be 0. So what is done here? See, we are doing here 5 minus 2, 2. What is done? We have done changing first row. In first row, what is done? In first row, third row multiplied by 1 by 2. Third row is multiplied by 1 by 2 and added a product in first row. So first row is changed. This is performed in this matrix. And hence, same operation we perform parallel on this matrix. So doing same, first row multiplying by 1 by 2 and adding in, third row multiplying by 1 by 2 adding in first row. See, multiply this by 1 by 2, so 5 by 2. 5 by 2 add here. 5 by 2 plus 1 by 2, 6 by 2. 6 by 2 is 3. Multiply this 1 by 2. So minus 1. Add here minus 1. So minus 1. Multiply this by 1 by 2. Add here. So 1 by 2 into 2 is 1. Adding here, this will be 1. So change will be in first row. So this 0 is obtained. Now we get this 0. This 0. Here we want 0. Using third row, in the same step, we are getting 2 zeros at a time. Here no sequence of a step is important. You can get this 0 first, then this 0 at second step, or get this 0, after that get this 0. So any 1 0 from these two you can get first, then get on second 0. So here now for second 0, look here. This is 5 by 2. So to get here 0, I have to multiply third row by 5 by 2. And I have to add in, subtract in second row. Now I would subtract. So see, these are zeros, so these numbers will not be factored. Now this multiply by 5 by 2 and subtract here, so this will be 0. So what is done? Change in second line. In second line, what is done? Third row is multiplied by 5 by 2 and subtracted in second row. So say, same we do here. This number multiply by 5 by 2. 5 by 2. So 25 by 2. 25 by 2, subtract here. So minus 5 by 2, minus 25 by 2, so minus 30 by 2. So it will be minus 50. Again, multiply by 5 by 2. Minus 2 into 5 by 2 is minus 5. Minus 5, subtract here. 1 minus 5, that is 1 plus 5, it will be 6. Say again, multiply this by 5 by 2. So minus 5. And we are taking here subtraction. So from 1, product is subtracted. So 1 minus 5, 1 minus minus 5, so plus 6. Then 2 multiply by 5, so product is 5. Then subtract here, so 0 minus 5. So this 0 is out. So this was sixth step. 1, 2, 3, 4, 5, 6 step, 7, 8. Or do this 7, this 8. Now last step, this will be ninth step. In ninth step, we want here 0. But already there is 0. So no need to do any more. Otherwise, if this value is non-zero, then we have to take help of second line. Using help of second line, we can get 0. So remember, in this procedure, whenever you get digits in this sequence, say in first step 1 is obtained, second step get 0, third step get 0, but when you get next digit, the previous digit should not be disturbed. In third step, when you are doing here to get 0, then this 0 or 1, these two digits already you have derived. This digit should not be disturbed. Okay. Should remain unchanged till last step. So 1, 0, 0, then 1, then 0, then 1, then get here 0, 0. Then at last get here 0. So this is identity matrix. It is I. So starting was A equal to I into A. And at last, performing this procedure, A is converted into I. And whatever is performed to convert A into I, parallel change is obtained in matrix I, which was here on the right hand side. So I is converted into this matrix. So this is B and this is A inverse. Therefore, E inverse is 3 minus 1 1 minus 15 6 minus 5 5 minus 2 2. It is A inverse. Now same question. How to find inverse of matrix using column operations? Just I explained using the row operations, now using column operations. In theory part I discussed starting of that method using a column operation. So here starting is, we know that E is equal to E into I. If A is equal to E into I. Starting is important. In row operation, starting was E equal to I into A. Here A equal to E into I. Now we give value of A. A is 2 0 minus 1 5 1 0 0 1 3 equal to this A keep as it is. Here identity matrix is on right hand side. Right to A. Right side to A. So till last step, this A we will forward as it is. But in every step we shall use column operations. Say in last question, in every step we use, in last method, in every step we use the row operations. Everywhere see I use R1, R2, R3. Nowhere column operation was used. Now everywhere we shall use column operations. Mixture of column operation and row operation is not allowed. In every step use column operation if you do by this starting. Now in this method sequence, in that method, row operation, we were going through this sequence. First step 1, 0, second step, third step, fourth step, fifth step, sixth step, 7, 8, 9. So we go through this procedure. We were getting digits in columns. In row operation, going through columns. Now in column operation, first of all we get 1, then 0, second step, then third step, then fourth step, then fifth step, then sixth step, then seventh and eighth step, then ninth step. This is last step. So 1, 0, 0, then 1, 0, then 1, then these 2 zeros, and last this will be 0. So this will be the procedure, sequence of getting digits 0 and 1. So first of all, here we want 1. We want 1 first step. So to get here 1, remember we are using only column operations. So to get here 1, what we do? We divide column 1 by 2. Dividing column 1 by 2. So here 1 can be obtained. See other way of getting 1. If we subtract the third column, if we add third column in first column, then also we can get 1. That will be better. So doing that way, same operation we will perform here. So that is, I am adding third column in first column. So 2 minus 1 is 1, 5 plus 0 is 5, 0 plus 3 is 3, equal to 8 into, adding here 0, 1, 0 plus 0, 0, 0 plus 1 is 1. So what is done here? Change is done in first column. In first column, third column is added. So change will be first column. Second column as it is. This will be as it is. 0, 1, 0, 0, 0, 1. So this one can be obtained by dividing first column by 2, or we can get here 1 by this procedure also. Remember, we are having 3 operations. Any operation, whatever is convenient, you can use. So 1 is obtained. This is done. Now concentrate here. Here we want 0. So here we want 0. Already done. Already 0 is there. So no need to do in second step. Now set third step. Get here 0. Now we want here 0. So to have here 0, it can be done by adding first column in third column. Adding first column in third column, here 0 can be obtained. So that is 1, 5, 3, 0, 1, 1. Now this I am adding in third column. So 1 plus 1, 0. 5 plus 0 is 5. 3 plus 3 is 6. Equal to. So whatever is done here, same I am doing here. Adding this in third column. 1, 0, 1. 0, 1, 0. So adding here 0 plus 1 is 1. 0. This will be 2. So what is done? Change in third column. In third column, First column is added. So this 0 is omitted. So first step, second step, third step. Now fourth step. Focus here. Here we are going to set 1. See. First, second, third. Now focus here. Here we want 1. Already 1 is there. So no need to do anything. So 1 is done. Next step, set here 0. So focus here. We want here 0. So what we do? We take help of second column. Multiplying this by 5 and subtracting here, this can be converted into 0. So now I am multiplying second column by 5, subtracting here. So 1, 5, 3, 0, 1, 1. Now second column multiplied by 5, adding in third column. Multiplying this by 5, no effect. Multiplying this by 5, adding a subtracting in third column, this will be 0. Multiplying by 5, subtracting in 6, 6 minus 5 is 1. Equal to, same procedure here. Multiplying this by 5 and subtracting here. See 1, 0, 1, 0, 1, 0. Now here 0 into 5 is 0. So here no effect. 1 into 5 is 5. Subtract here. So minus 5. Here this is 0. So no effect. So keep 2 as it is. So this is done. Now focus here. We want here 1. Look here. Already 1 is here. So this is done. See, we are getting digits 1 and 0 in this way. First step 1, then 0, second step, third step, fourth step, fifth step, sixth step. We have finished till this sixth step. Now, using this column, we are going to have these 2 zeros. That will be 7 and 8 step. So look here. Using this column, we are going to set here 2 zeros. So in the same step, these 2 zeros can be added. So to get here 0, we multiply third column by 3 and subtracting here. Because of these 2 zeros, this will not be affected. So 1, 5, this will be 0. 0, 0, 1. First we finish that procedure on right hand side. This was multiplied by 3. Subtracted here. So 1 into 3, 3. Subtract 3 here. So minus 2. Minus 5 into 3. Minus 15. Subtract here. So plus 15. 2 into 3, 6. Subtract here. Minus 5. So here, change we have done in first column. What is done in first column? Third column is multiplied by 3 and subtracted in first column. So this 0 is obtained. With that, in the same step, we are also getting this 0. So to have here 0 is subtracted. So subtracting this here, this will be 0. Here no effect. So here, subtracting this value, this column in second column, here minus 2, this will be 6, this will be minus 1. So that means in change in second column. In second column, third column is subtracted. In this step, what we did in this step, reason we should take here, it was getting 1 0 0 1, then in that step we obtained that 0. So this was multiplied by 5 and subtracted here. So second in third column was multiplied by 5 and subtracted in third column. Okay. Inside I am showing the reason. Now last step, last 0. This 0 can be obtained by taking help of second column. Now second column multiplied by 5, subtract here. So this will be 1 0 0 0. So here 1 0 0, here 0 0 1 0 0 1. What is done here? This is multiplied by 5 and subtracted here. So similarly, this multiplied by 5. So minus 5. Subtract here. So minus 2 minus 5. So minus 2 plus 5. That is 3. Multiply by 5. 30. Subtract here. So minus 50. Multiply by 5. Minus 10. Subtract. So plus 10. Minus 5 plus 10 is 5. Minus 1 6 minus 2 1 minus 5 2. What is done here? In first column, second column, after multiplying by 5, subtracted in first column. And look, on the left hand side, we have obtained unique matrix. So when using the using column operations, on the left hand side, we are getting digits in this sequence. 1, then second step, third step, fourth step, fifth step, sixth step, then seventh step, then eighth step. This way. Then these 2 zeros and a last step. Using the row operations, we go through columns. 1 0 0. Using the row operations. Then 1 0. Then 1. Then 0 0 0. So this is E inverse. Therefore, E inverse is 3 minus 1 1 minus 15 6 minus 5 5 minus 2. Now using the row operations, getting inverse. Using the row operations. So here starting is, we know that A is equal to I into A. In row operation, keep I on left side. When performing column operation, keep I on right side. So A is equal to I into A. A is 2 minus 3 3, 2 2 3, 3 minus 2 2 equal to 1 0 0 0 1 0 0 0 1 into A. This A we will forward as it is till last step, and in last step this will be converted into unit matrix, identity matrix. So converting this into identity matrix, first step is get here 1 using the row operations. So to get here 1, look here. Here this is 2, in this line there is 3. So to get Here 1, what we do? First of all, I divide this by 2. Dividing by 2, or second way, third row I subtract in first row. Because if you don't write fractions, this is bad. Third row subtract in first row. So 2 minus 3 is minus 1. Minus 3 minus 2, that is minus 1. 3 minus 2 is 1. First row, from first row, third row is subtracted. Same thing here. 0 subtract here, so 1, 0. Third row we are subtracting first row, so minus 1. 0, 1, 0, 0, 0, 1. Here 2, 2, 3, 3 minus 2, 2. What is done here? In first row, third row is subtracted. Here it is 2. We want 1. So to have 1, first of all we set here minus 1. Because subtraction gives minus 1. Now to get here 1, I multiply elements of first row by minus 1. So multiplying this element by minus 1, so this will be 1, 1, minus 1, 2, 2, 3, 3 minus 2, 2. Same here, multiply this by minus 1. So minus 1, 0, 1, 0, 1, 0, 0, 0, 1. So what is done here? First row, all elements are multiplied by minus 1. So R1 is multiplied by minus 1. So 1 is okay. We are doing by row operations. 1 is okay. After getting 1, next step, below 1 get 0. So to get here 0, take a help of first line. After getting 1, easily these two values can be converted into 0. So what do I do? Multiply first row by 2, subtract here. Multiply first row by 2, subtract here, so 0. Multiply this by 2, subtract here, so 0. Multiply by 2 now. So minus 2, subtract here, so 5. 3 minus 2, 2. Same we do here. First row is multiplied by 2 and subtracted here. Multiplying by 2, so minus 2, subtract here, so plus 2. No effect. This will be minus 2. 0, 0, 1 into 8. So what is done? Second row is changed. In second row, after multiplying first row by 2, we have subtracted. So the 0 is okay. First step 0. First step 1, second step 0. Now third step, we want this 0. We are getting in the sequence. Now to have here 0, again you take help of first row. Whenever you set 1 in first order, use that row in getting 0, 0 in that one. So we have to multiply this by 3. Multiply by 3, subtracting here, this can be 0. So that is equal to 1, 1 minus 1. Multiplying 3, second line also will be as it is. 0, 0, 5. Here, minus 1, 0, 1. 2, 1, minus 2 into 8. Now focusing here. Multiply by 3, subtract here. Multiplying 3, subtract there, so 0. 3 subtract there, so minus 5. Multiply 3, so minus 3. Subtract here, so plus 3. 2 plus 3, 5. Same we perform here. Multiply 3, so minus 3. Subtract here, so plus 3. Here no effect. Multiply 3, subtract here, so minus 2. So what is done? Change is in third row. In third row, first row is multiplied by 3 and subtracted in third row. So this is done. So this 0 is okay. Now next step, we want here 1. We want here 1. That is fourth step. So focus here. We want 1. So to have here 1, if you add first row in second row, here you can get 1. But this 0 will remove. It will be disturbed. Remember, whenever getting next digit, previous digits should not be removed. Without disturbing previous digit, create new digits in required sequence. So here, adding the first row in second row is not allowed because here you will get 1, but this will be disturbed. That is not allowed. So think other way. So what we do to get here 1, third row I multiply by minus 1 by 5 and adding here this will be 1. Third row multiply by minus 1 by 5. So 5 cut, 1 is left, add here 1. So 1 can be created. And this 0 will not be affected because below this 0 there is here 0. So this 0 will not be affected. So that is next step. The change will be in second row. What we do in second row? Third row multiply by minus 1 by 5 and adding in second row. So 1, 1, minus 1, 0, minus 5, 5, multiplied by 1 by 5, this is unaffected, minus 1 by 5, adding here, so 1, multiply this by minus 1 by 5, so minus 1 is left, add minus 1 here, so 4. Same procedure here. Minus 1, 0, 1. 3, 0, minus 1. Change will be in second row. Now, third row multiply by 1 by 5 and subtracting here. So 3 by 1 by 5, multiply this by 1 by 5. So 3 by 5, 3 by subtract here. So 2 minus 3 by 5. 2 minus 3 by 5. That is 10 minus this 7 by 5. So this will be 7 by 5. Then this is 0, so no effect here. Now here minus 2 multiplied by 1 by 5. So it is minus 2 by 5. Minus 2 by 5 subtract here. So plus 2 by 5. So minus 2 plus 2 by 5, that is minus 10 plus 2, minus 8 by 5. Minus 2 by 5, subtracting there, plus 2 by 5, so minus 10 plus 2, okay, minus 8 by 5. So this 0, 1 is okay. Now we get this 0, for which we take f of second row. Second row now multiply by 5 and adding here. Second row, change will be in third row. What we are doing in third row, multiplying second row by 5, adding in third row. So under this operation, here 1 1 minus 1 0 1 4. Now this is 0, multiplying by 5, add here 0, multiply 5, so 20, add here, so 25, equal to minus 1 0 1, 7 by 5 1, minus 8 by 5. Now multiply by 5, so 7, add here, so 7 plus 3 10, multiply by 5, add here, so 5, multiply by 5, so minus 8, add here, so minus 10, into 8. So this is okay. Next step, get this one. So to get this one, we divide by 25. Last row divide by 25 because these are zeros. So dividing by 25, 0 0 1. Similarly, this number we divide by 25. Dividing by 25, so 2 by 5. Divide by 25, 1 by 5. Divide by 25, minus 2 by 5 into 8. So what is done? Third row is divided by 25 or multiplied by 1 by 25. So this is okay. Now we get these two zeros. At a time. So for which? 7. To get here two zeros, you can get 0 in any order. First of all, get this 0, then get this 0, or get this 0, after that get this 0. So this is 0 0 1. So direct if I add here, so this will be 0. So 1 1 0. This is added. Adding third row here, we get 0. So same procedure I do here. This is 2 by 5, 1 by 5, minus 2 by 5. Now this is added. So this number I am adding here. Minus 1 plus 2 by 5. Minus 1 plus 2 by 5 is minus 5 plus 2, minus 3 by 5. So minus 3 by 5. Then adding here, this will be 1 by 5. Adding here 1 minus 2 by 5, so 5 minus 2, 3 by 5 into 8. 2 by 5, 1 by 5 minus 2 by 5. So this 0 is okay. Now this 0. To get here 0. Use same line. Multiply by 4, subtract here. Multiplying this by 4, subtracting here. So 0, 1, 0. So here, multiplying this by 4 and we are subtracting here. So 4 equal to 8 by 5. 8 by 5 subtract here. So minus 1 by 5. Multiply by 4, 4 by 5. 4 by 5 subtract here. 1 minus 4 by 5. So 1 by 5. Multiplying by 4, it will be minus 8 by 5. Minus 8 by 5, subtract here. So it will be 0. So multiplying and subtracting. Multiplying by 4 and subtracting. So this steps showing here. First of all, first row is changed. In first row, third row is added. And then in second row, third row, after multiplying by 4, it is subtracted. Now last step, get this 0. So to get this 0, we use this one. Because setting here 0, this digit should not be disturbed. And say because of here these two zeros, these are not disturbed. This will not be disturbed. So subtracting this here, subtracting here 1, 0, 0, 0, 1, 0, 0, 0, 1. Subtracting here minus 3 by 5 plus 1 by 5. So minus 2 by 5. 1 by 5 minus 1 by 5. 0. 3 by 5. Minus 1 by 5. 1 by 5. 0. 2 by 5. 1 by 5. Minus 2 by 5 into A. So what is done here? In first row, second row is subtracted. So say here in the beginning this was A, and A is converted into identity matrix. In converting identity matrix, we follow the sequence. And nowhere column operation is used, everywhere row operation. In any step, don't mix column operation. If you perform by column operation, in every step do only column operation, not mix row operation. So this is A inverse. Therefore, A inverse is minus 2 by 5, 0, 3 by 5, minus 1 by 5, 1 by 5, 0, 2 by 5, 1 by 5, minus 2 by 5. So it is A inverse. To obtain inverse, using the row operations. When we find inverse using a row operation, starting is E is equal to I into 3. This is first step. And in last step, this will be converted into I. And when we perform using the row operation, we set sequence of 1 and 0 by this way. First step 1, then 0. 1, 0. This is 2 by 2. Similar procedure we perform in 3 by 3. So set digits in column, direction of column. 1, 0, then 1, then 0. Go through this sequence. And when we do this by column operation, then set 1, then 0. 1, 0, then 1, then 0. In this direction. Using column operation. Here, A is I into A. A is 4, 5, 3, 4 equal to 1, 0, 0, 1 into 8. Now converting this in identity matrix using the row operation. So concentrate on this procedure. First of all, get here 1. So for that, we subtract second row. So 4 minus 3, 1. 5 minus 4, 1. 3, 4. Second row is subtracted. Similarly here, 1 minus 0 is 1. 0 minus 1 is minus 1. What is done here? In first row, second row is subtracted. So 1 is okay. This is done. Now we get 0. To get here 0, first row multiply by 3 and subtracting second row. Multiplying this by 3, subtract here, this will be 0, this will be 1. Same procedure here. Multiply by 3, subtract here, so minus 3, multiply 3, subtract here, so 4, into 8. So here, what is done? In second row, there is change. In second row, first row multiplied by 3 and subtracted. So this is performed. So this is done. Now get this one. So when we are getting this 0, automatically 1 is also obtained. So that is also done. Now last step, get this 0, for which we use help of second row. So subtracting the 0. Here 1, 0. This is subtracted. Similarly here we subtract here. So 1 minus minus that is 4. Minus 1 minus 4 that is minus 5. Minus 3, 4 into 8. So here in first row, third row is subtracted. So this is done. So on left hand side, identity matrix is obtained. So whatever is obtained here, this is A inverse. So A inverse is 4 minus 5 minus 3, 4. If we perform this question by column operations using column operations, then starting will be in row operation we use this equation. In column operation, let A is equal to I into A is equal to A into I. That is A is 4, 5, 3, 4. This A keep as it is 1, 0, 0, 1. In this method, this A which is on the right side will forward as it is. Here we set A on the left side, that will forward as it is. Now, column operation, first we set this one, but using column, not row. So to set here 1 using column, what we do? Either we multiply this, either we divide this by 4. Divide by 4 or subtract the second column in first column, you will have here minus 1. Then in next step, multiply that column by minus 1, you will get plus 1. So you can do by any means. Let me divide by 4. So dividing by 4, this is 1, this is 3 by 4. 5, 4. So here, this we divide by 4. So what is done? First column is divided by 4. We perform only column operation, and this method only row operations. So this one is obtained. Now look at this 0. This value we multiply by 5 and subtract here. So 1, 3 by 4. Now multiply by 5, subtract here, so this is 0. Multiply by 5, so 15 by 4. 15 by 4 subtracting here. 4 minus 15 by 4. So 16 minus 15, 1 by 4. And same procedure here. This is multiplied by 5, subtracted here. So multiply this by 5, subtracting here. So this will be minus 5 by 4. Here no effect. So what is done? Change in second column. In second column, first column is multiplied by 5 and subtracted in second column. So this is okay. Now here we want 1. Third step. To get this 1, we multiply second column by 4. So multiply second column by 4, 0, 1. Same on other side. Multiply this by 4. So what is done? Second column is multiplied by 4. Second column is multiplied by 4. So here it is 1. This is 1. And last step, we get 0. So to get here 0, we use second column. Second column, multiply by 3 by 4 and subtract here. So multiplying this by 3 by 4, 0 into anything is 0. Subtract here, so 1 is unchanged. 3 by 4, so here 0. 0, 1 equal to, similarly here, multiplying this by 3 by 4, so minus 15 by 4. Minus 15 by 4, subtract here, so plus 15 by 4. Total 16 by 4, that is 4. Here multiply this by 3 by 4, we get 3. And subtract 3, so here minus 3. Minus 5, 4. So here, what is done? In first column, after multiplying second column by 3 by 4, it is subtracted. So here, this is a unit matrix or identity matrix. So that's why this is inverse. So A inverse is equal to 4 minus 5 minus 3, 4. Using column operation, perform only on column. Using row operation, perform only on rows. See, nowhere you can see column operation. Don't mix column and row. See here, we know that A is equal to I into A. We are doing this using row operations. This question we are solving using row operations. So starting is A equal to I into A. So it is equal to 6 minus 3 minus 2 1 equal to 1 0 0 1 into A. Now first step, we want here 0. Sorry, we want here 1. So to have here 1 and using a row operation, if we divide this by 6, so 1 can be obtained. So divide first row by 6. So this will be 1. Dividing 6 minus 1 by 2. Similarly on right side, divide by 6. Divide by 6. So what is done? First row is divided by 6. Second row keep as it is. So 1 is obtained. Next, we want here 0. So to have here 0, we multiply first row. First row multiply by 2, adding second row. So change will be in second row. In second row, after multiplying first row by 2, we are adding. So next step, we perform this two step. In second row, we are adding elements of first row after multiplying by 2. So multiplying this by 2, 2 into 1, 2, add here, so 0. 2 into minus 1, 5, that is minus 1, add here, 0. Same thing here. Multiplying this by 2, add here. So this will be 1 by 3, add here 2 by 3. Now, in theory part, in the beginning, what I explained, in this procedure, performing the row operations at any step, if you get all entries 0, it's third step, we are getting all entries 0, then stop the two step. A inverse does not exist. On the left hand side matrix, in second row, all entries are 0. Therefore, A inverse does not exist. So remember, finding inverse of matrix of order 2 or order 3 at any step, if you are get all entries 0, then inverse does not exist. If you do using the row operations, if you get entries in the row, inverse does not exist. If you are doing by column operations, and if you are getting all zeros in any one column, then inverse does not exist.